Hello everyone. Today I am going to discuss this Google Intern OA 2021 complete session, which consists of two problems. So, without wasting much time, let's get started. So, let's proceed to problem one. Yeah, this problem is closest pairs. Let's read the problem first. So, we are given a tree of n nodes. The tree is rooted at node 1. Okay, so the tree is something like this, where the root node is 1. Okay, and each tree node has a value associated with it. Okay, and it is represented by value of I. Okay, nice. For each node you are required to determine the closest ancestor that contains value that are co-prime to the current node value. If no such value exists, then print -1. Okay, so it is saying if I am having this type of a graph, this type of a tree, let's say. So for each node, let's say this is node 1, this is 3. Let me redraw the tree. Yeah. So the question is something like this. We are given a tree like this, right? Where the root node is always 1. Other nodes can be anything. This is, let's say, node 2, 3, 2, 5, 4, and let's say 6. And these are the edges, right? Let's let's say this is the given tree, and there is a value assigned to each node. Let's say root node is having value 5, it is having 10, it is having 3, it is having 2, it is having 1, and it is 6. Yeah, so what I have to return as output is, it is saying that I am required to determine closest ancestor for each node that contains a value which is co-prime to the current node value, right? So first let's discuss what is co-prime. So two numbers a and b are co-prime if and only if their GCD, the greatest common divisor, is 1. That means there is no other common divisor in between two numbers a and b. That means these are co-primes. So if this condition holds that GCD of a comma b is 1, that means a and b are co-prime to each other, right? So let's now look at this problem, look at this test case where I am having this type of a tree and these are the values assigned to each node. So for node 1 there is no ancestor, so the value would be -1. For node 2 the only ancestor is 1, but let's see, the value assigned to node 1 is 5 and value assigned to node 2 is 3, and these are co-prime to each other, so the closest ancestor for node 2 is 1. Let's see, for node 3 the only ancestor is 1, but the greatest common divisor of 5 and 10 is 5, which is not 1. That means these values are not co-prime to each other. So for node 3 also the answer value will be -1. And for node 4 uh, there are two ancestors, 3 and 1. Let's see, uh, with node 3 the value is 10. 10 and 4 are not co-primes, whereas 4 and 5 are co-prime numbers. That means for node 4 the closest ancestor which is having co-prime value is 1. And let's calculate for node 5. For node 5 also the closest ancestor which is having value co-prime with it is node 1, not the node 3. Let's see, for node 6. For node 6 also the closest ancestor is 1. So this will be the required output for this given input. So that's how I have to calculate the answer vector. I am having another 5 test cases also, and the input format is like this. I'm having t test cases and n nodes, n minus 1 edges, okay, and I have to print n space integer, that is the answer vector, let's say, which is storing the closest ancestor for each node I, such that the value of node I and the closest ancestor is co-prime. If there is such closest ancestor existing, that then we have to return that closest ancestor, otherwise we have to return -1 for that particular node, right? So for all these 5 inputs I have drawn the tree, and let's quickly calculate the answer vector for all these test cases. Let's say I am considering this test. For node 1 the value will be -1, the answer value, and for node 2 the closest ancestor will be 1, because these values are co-prime to each other, right? So for node 3 the 2 and 5 value are co-prime to each other, so for node 3 the closest ancestor is 1. For node 4 there are two ancestors existing, node 2 and node 1, and node 2 is the closest ancestor which is having co-prime value with 4. As you can see here, 4 and 3 are co-prime, also 4 and 5 are also co-prime to each other, but node 2 is closest, so we will take node 2 here as answer. For node 5 we will be having value, yeah, node 2, because 3 and 7 are co-prime to each other. Yeah, this should be the output here. And for all these test cases we can calculate the answer vector in similar manner. Let's say for this, answer value for node 1 is again -1, because it is not having any ancestor. For node 2 the only ancestor is 1, but the values of node 2 and node 1 are not co-prime to each other, so the answer for node 2 is -1. And again let's see for node 3. So node 3 is having two ancestors, 2 and 1. Yeah, and both these values are co-prime to 7, so I will take the closer one. So the node 2 will be the answer for node 3, right? So this will be the answer vector for this test case. Let's calculate the answer vector for this test case also. Not this one, let's calculate for this one. So again for node 1 the answer value will be -1. For node 2, as you can see, the 5 and 9 are co-prime to each other, so the answer will be 1. And for node 3, 3 and 9 are not co-prime to each other, so I will take -1 for this. And let's see for 4. For 4 I can directly see 5 and 2 are co-prime to each other, so for node 4 node 2 is the closest ancestor. For node 5 8 value and 5 value are co-prime to each other, again I will take 2 as answer. For node 6 again 3 is having value 3 and it is having value 6, which are not co-prime to each other. Let's now check this node. 9 and 6 are also not co-prime to each other, so for this answer will be -1. I can check this test case. -1, 1, -1, 2, 2, -1. Yeah. So that's how I can calculate the answer vector. Let's quickly observe something. So you can see that for each node to calculate the answer value, uh, I need to have some information about the values of ancestor of that particular node, right? That means, let's say, how I can gather that information. One way is I can use DFS. How? Let's say I'm taking uh, this uh, this tree. Initially, I am at this node. Let's say I'm running a DFS from this root node. Whenever I'm going to its adjacent node, I am also one thing. In DFS function, I am considering node and the path. This path vector will store the this path vector will store the nodes which are occurring in the path from root to that particular node. Let's say I am considering this node. Whenever I am at this node, the path vector will be containing 1 and 2, because to reach 5 I need to go from 1 to 2, then from 2 to 5, right? So the ancestors for this particular node is 1 and 2. I can store these ancestors using DFS. let's quickly move to its pseudocode. So I am using DFS function. In DFS function, I am passing the current node u and the path vector to store the path, not the path, to store the nodes present in the path from root to that particular node in DFS call, right? So the first step in this DFS is always marking visited. So first of all, I will mark this particular node as visited, and then I will iterate to this path. This path is containing all its ancestors in sequential manner, like from top to down, top to bottom. But I need to find the closest ancestor, right, which is having co-prime value. So I have to iterate the path in reverse manner so that I can achieve the closest ancestor, which is having co-prime value with the current node. So I will iterate in the path to find the closest ancestor with co-prime value, right? If such ancestor exists, then the answer of that particular value, that particular node will be that ancestor only. Otherwise, if that ancestor doesn't exist, then the answer value for this particular node will be -1, right? And after considering the DFS from this particular node u to all its children, whenever the DFS call again comes to this node, basically I'm considering this type of a call where, yeah, let's say I am at this node. When DFS call returns from this to the previous call, I need to remove this 2 from the path vector, because in next calls this should not be present in the path vector, because I am considering all these nodes which are present, which are in the path from root node to the successive nodes, right? So whenever the DFS call returns to the previous call, to the ancestral call, I should remove the current node from the path vector, right? So that's why I have, yeah, that's why I have popped back the current node from the path, and after writing this DFS function recursively, I can, yeah, I can update the answer vector completely. So let's now look at the time complexity and the space complexity for this algorithm. So I am using external space for storing visited, like visited status, and also adjacency list. So yeah, the space complexity will be, it will be big of n almost. So let's see what it is. What's the time complexity for this algorithm? In general, in normal DFS, the time complexity is big of n plus m, which is n is number of nodes and m is number of edges. So here the number of edges is n minus 1 because it is tree. So the time complexity, if it was the normal DFS, it should be of time complexity big of n. But I am iterating to path vector, which can be at max, it can be of at max size n. So in worst case scenario, this DFS function can be of time complexity big of n square. So this will be the time complexity and space complexity for this particular code. Let's quickly code this question now. Let's see what are the input formats for this problem. Initially I am having t test cases, and in each test case I am having n number of nodes, and then I am having values. Okay, n list. Okay, so let's now quickly code this question. Yeah, I am having n number of nodes, and before taking edges into consideration, let's just create vector val of size n plus 1, because I am considering one based indexing. Adjacency list vector of size again n plus 1, right? And also I have to consider visited vector of size n plus 1, and I have initialized each value of visited as false initially, And yeah, let's just now take the values assigned to each node. After that, I have to create adjacency list. There are n minus 1 edges, so loop will be from I equals to 1 to n minus 1. Let's take u and v as input. See, yeah, agency of list, agency of u dot push back v, and agency list of v dot push back u. I'm considering undirected tree. Okay, so after creating this agency list, what I have to do is I have to create a answer vector of size n plus 1, which will store the answer values for each node, right? And also I have to create a temporary path vector in which I will store the uh, all the nodes which are occurring in a path from root to that current node. Let's quickly now implement the DFS function as I have discussed in this pseudocode. So I'm writing lambda function for DFS. Yeah, it is of void return type. It is taking only one node as input, and also a vector which will store the path. So vector. Path. First of all, step 1, I have to mark this node visited. Then I have to iterate in reverse manner in the path. So first let's quickly store the size of this path in sz variable, uh, sz minus 1, because I have to iterate in reverse manner so that I can calculate the closest ancestor. Yeah. So if value of, I have to check whether the GCD of value of this current node I, node u, and value of path of I, the current the ancestor. If this GCD value is 1, that means I have found I have like yeah I have found a valid closest ancestor. So let's mark the flag as 2. I have found a ancestor. Initially the let's say initially the flag was false, right? And after marking it, just update the answer value for this particular node as this ancestor, right? And let's break the loop because I have already calculated the closest ancestor. After coming out of this loop, if the flag value is false, that means there is no yeah that means there is not any there is not that means yeah that means there is not a single ancestor for that particular node that is having co-prime value with this particular node. So for that value, for that scenario, I need to uh, store minus 1 in place of answer of u. Yes. And let's now just update the path vector, the current node u in path, and let's explore the adjacent nodes of this node u. If the adjacent node is not visited, let's call the DFS comma path, right? And after when I am returning this from this DFS call to the previous DFS call, I need to remove this current node from the path. So path dot pop back. So that's how I have implemented this DFS function. Let's now call the DFS function from root node 1 and the path let's pass the path vector. I have created path vector or not? Yeah. So I have passed the path vector. So after this DFS call, I have already updated the answer vector. So let's now quickly print this answer vector for all the nodes. Okay, let's now run the code. Let's see if there is any error or not. Check whether I am having correct output or not. Minus 1, 1, 1, 2, 2. Minus 1, 1, 1, 2, 2. Minus 1, minus 1, 2. Minus 1, minus 1, 2. Minus 1, minus 1, minus 1, 3. Minus 1, minus 1, minus 1, 3. Yeah. Minus 1, 1, minus 1, 2, 2, minus 1, right? So that's how you can implement this code. Okay. So let's now quickly proceed to the problem 1. You can see that this problem is easy to medium problem of tree, or you can say graph, which is involving only DFS concept and some kind of backtracking because I am popping back that particular current node from the path vector. So that's how you can proceed to this problem. Let's now quickly uh, let's proceed to the problem 2. This is a hard problem. So this is XOR queries. Let's say what this problem is saying. In this problem, we are given a list S, which is initially containing a single value 0, okay, and we have to perform q queries on this particular list, and queries can be of two type, 0 comma x and 1 comma x. 0 comma x defines is defined as insert x in the list. It is not mentioned whether we have to insert x at last of the list, at front of the list, or at any position of the list, okay. So another query is 1 comma x, in which for every element in the list, I have to replace the element with a XOR x. Okay. And after performing q queries, I need to return the list values in increasing order. As I have to return the values in sorted manner, that means the order in which I insert the x in the list is not a matter. Like, it doesn't matter. I can insert at front, I can insert at uh, back, I can insert at middle, I can insert anywhere. So I will choose to insert at back, and I will use vector for this list. So the constraints for this question is uh, there are t test cases and q queries. So the number of test cases can be up to 10 to power 3, and number of queries can be up to 3 into 10 to power 4. So let's see some inputs. Okay, so initially I am having 0, right? In each test case, I am having initially 0 inside my list. So let's try this first test case. So after first step, where I am inserting 5, the list will be something like this, 0 comma 5. So the second after second step, my list will be something in second step, I have to XOR all the elements with 3. So 0 XOR 3 is 3, and 5 XOR 3 is 6. You can check. 5 is 101 and 3 is 011. So the XOR value for both this number is 110, which is 6. So again 3. After third step, I have to insert 2. So the list will be something like this, and I have to return the list elements in sorted manner. So the final output will be 2 comma 3 comma 6, which is matching. So again, for second test case, initially I'm having 0 inside my list, and after first step, my list will be something like this, 0 comma 1, because I am inserting 1. After second step, my in which I am inserting 2, my current list will be 0 comma 1 comma 2. And after third step, in which I have uh, taking XOR with 1. 0 XOR 1 is 1, 1 XOR 1 is 0, and 2 XOR 1 is 3, because 2 is 1 0 and 3 is 1 1. Sorry, yeah, 0, where 1 is 0 1. In its XOR of 2 and 1 is 1 1, which is 3. And the last step for this test case is take XOR with 2. So 1 XOR 2 is 3, 0 XOR 2 is 2, and 3 XOR 2 is 1. So this is the final list, and after sorting this list, the output will be 1 comma 2 comma 3. Okay, that's in similar manner I can calculate the output for test case 3 and 4. So let's quickly discuss the brute force solution, which is quite simple. So there are two kinds of queries, 1 comma x and 0 comma x. Whenever whenever I am having 0 comma x kind of a query, let's insert x at back of the vector. And whenever I am having this kind of query 1 comma x, let's take the like let's iterate over all the uh, elements of current list and replace the elements as element comma XOR. You can directly see that in worst case scenario, this brute force solution will take time complexity of big of uh, q square, right? And space complexity of big of q, because I am building uh, answer vector or answer list, which can be of size q at max, right? But q is up till 10 to the 3 into 10 to the power 4. So the q square solution will be of time complexity big O of 9 into 10 to the power 8, which will definitely give me TLE for this solution. So to optimize this solution, let's try to observe something. You can see whenever there is, uh, let's say, let's use this space. Let's say I am having this type of list, and currently I am inserting a new number here. So insertion of new number is not dependent on previous numbers. Basically, I'm saying you have XORed the previous number, let's say with X or Y or any number, but the new inserting number is not depending on all the previous numbers. So this number can only be changed uh, by the queries of type 2 in which I am taking XOR. I can, let's take a new example where, not new example, let's take this example only. Uh, let's copy this. Yeah, depend. Yeah. So I am having this input. Initially, in this test case, I am having 6 queries. First query, second query, third query, fourth query, fifth query, and sixth query. So initially my vector is, let's say, answer vector is 0, which is initially having 0. So after this step, in which I am inserting 4, this will be something like 0 comma 4, and after this step it will be 0 comma 4 comma 2, right? So after this step where I am taking XOR of all these number with 6, the current answer will be something like this: 0 comma 0 XOR 6 comma 4 XOR 6 comma 2 XOR 6, right? And again I am inserting a new number 1. So the current list will be something like this: 0 6 4 XOR 6. I'm not calculating the XOR values here. 2 XOR 6, and the new element which I am inserting is 1. You can directly see that this 1 is not affected by the previous queries of XOR, because for this one I am not taking XOR with 6, and in next step where I am taking XOR with 7, the current image of the list will be 0 XOR 6 XOR 7 4 XOR 6 XOR 7, 2 XOR 6 XOR 7, and my 1 will be changed to 1 XOR 7, right? So this is the current image of the answer variable. And after the last step where I am inserting a new variable 9, my current list will be 0 XOR 6 XOR 7, 4 XOR 6 XOR 7, XOR 6 XOR 7, 1 XOR 7, and the last value which I am inserting is 9. So after this complete dry run, you can easily observe that each value which I am inserting, so when I have inserted this 2, at the end of all the queries, this 2 will, I have inserted 2 here, yeah. After inserting this 2 can be changed to 2 XOR 6 XOR 7. And these 6 and 7s are coming from, I have inserted 2 at this step. And this 6 and 7 are present in these steps. Basically, I can observe, I can quickly make an observation, which is this. First of all, the order of insertion doesn't matter, which I have already discussed. The key observation for this problem is, whenever I insert an element x, right, because of the current query, then it's after all the queries are over, this value will be changed because of only those queries which are uh, upcoming queries. Basically, its value gets XORed with all the x of upcoming queries of type 1 comma x. I'm just saying that this value x will not be changed because of previous x values of XOR queries. This will only be changed by the upcoming query, which will be uh, of type 2, where I will take XOR. So by this I can see that uh, yeah every node which I am inserting in this array or list, after all the queries are over, this will be every node will be XORed with suffix XOR of all the queries after this current node, after this current query. So uh, I can optimize this previous brute force solution by uh, taking suffix XOR in consideration. Let's say, let's quickly discuss the pseudocode for this algorithm. Initially, I am taking suffix XOR value as 0, and I will uh, iterate queries in reverse manner because I am taking suffix XOR, and I am taking in reverse manner because let's say I am having this type of queries. Yeah, right. So initially, I am having suffix XOR as 0, and I am at this query, right? So let's say if this query is of type 1 comma x, so my suffix XOR will be changed to 0 XOR x, right? And let's say the previous query is of type 0 comma let's say 2, I am inserting 2. So this 2 can be changed only by the suffix XOR after this current query, right? So I will insert 2 XOR this suffix XOR, which is x only. And yeah, let's say this query is also of type 1 comma y. So the suffix XOR will be changed to x XOR y. And this particular query is of type 0 comma 3, so I have to insert 3. But this 3 will be XORed with this y and x both, which is suffix XOR, right? So I will push 3 XOR this suffix XOR, which is x XOR y. If you are not able to understand this, let's take an example. Let's take this example only first. Again copy this. Let's again copy this. Okay. So I have stored the queries inside a data structure so that I can iterate in reverse manner. Initially, my suffix XOR value is 0, and I am at this query, right? So this query is of type 0, 9, so I have to insert 9, and while inserting 9, I have to XOR this with suffix XOR. So the current list will be 9 XOR 0, which is 9 only, right? So the previous query is of type 1, 7. So I have to update my suffix XOR with, basically I am taking this suffix XOR as 0 XOR 7. So 0 XOR 7 is 7, right? So the previous query is of type 0, 1. I have to insert 1, but while inserting this 1, I need to take XOR with this suffix XOR. So the current picture of my list will be 9, uh, 1 XOR 7, which is 1 is 0, 0, 1, and 7 is 1, 1, 1. So after taking XOR, it will be 6, right? 6. Yeah. Now, the previous query is of type 1, 6. So I have to update the suffix XOR. 7 XOR 6 is 7 XOR 6 is 1 only, right? So for previous query, I have to insert 2. So I will insert 2 XOR 1, which is 2 is 1 0 and 1 is 0 1. So I will insert 3, right? Yep. And for this query, I have to insert 4, and the suffix XOR is again 1. So 4 XOR 1 is 5. But don't forget that initially I am having 0 inside my string, inside my list. So I have to take the suffix XOR again with 0 also. So let's push the suffix XOR of 0 with this. Let's push the XOR of 0 and the suffix XOR, which is 1. So after sorting this, it will be 1, 3, 5, 6 and 9, which is the correct output. So let's go to the pseudocode now. Yeah, this was the pseudocode. What I will do is, initially the suffix XOR will be 0, and I will iterate in queries vector or in any data structure in which I will store the queries in reverse manner. If the query is of type 0, x, I will insert x XOR suffix XOR. Else I will update my suffix XOR as x, and after considering all these queries, I have to insert the suffix XOR, taking XOR this of this 0 with this suffix XOR, because initially my list was having 0 element, the element 0, and after uh, fifth step, my list is ready to print. But after before printing this list, I have to sort the vector. So let's quickly code this question. Let's see the input format first. Yeah, let's quickly clear the sublime. Yeah. I am taking T test cases and Q queries. Let's take queries. I have to store the queries. Let's say I am taking a vector of pair to store queries. Not taking long. So queries. Let's store the queries. This query vector will be of size Q only. Wait a second. This is not 1. This is Q. So let's take input. So for each query, I am having integer a and x. Let's take them in uh, as input, and queries of I as pair a comma x I have stored in query vector. So after storing, what I have to do is I have to maintain a suffix XOR as 0 initially. Okay, suffix XOR value as 0 initially, and I have to iterate in reverse manner. Q minus 1 I less than equal to 0, I minus minus, and also I have to create a answer vector in which I will be storing the final image of the list. I am taking answer for this. So if the current query, first of all, let's store a current query inside this pair. There's queries of I, right? So uh, yep, A is equals to current query dot first, X is equals to current query dot second. If this A is of type 0, that means I have to insert a element X inside the vector. So I will insert answer dot push back, as I have already discussed, X XOR with suffix XOR. And if this is of type 2, where I have to update the suffix XOR value, I will update the suffix XOR value as I will be suffix XOR is XOR equals to X value. And after this completion of this query, this loop, I have to update. I have to insert the final modified element for the element which was 0 initially. So I will be pushing answer dot push back 0 XOR suffix XOR, which I have already discussed. And after this step, my answer vector is ready. Before printing answer vector, let's quickly sort this up. Answer dot end. So let's quickly print this now. I am using one base. Wait a second. Uh, Sir, I just have to print element. So element belongs to answer. Let's print the element. Out backslash n. Let's take the test cases. Five test cases. This is the first test case. Test case. Take fifth test case now. Let's quickly file this code if there is any error or not. Let's check if I am having correct output. For the first input, the output should be 236, which is correct. For second, it should be 123, which is also correct. For third, it should be 4,7, correct. 03711, correct. 13569, 13569, correct. So that's how you can code these questions. So let's quickly discuss the time and space complexity for this approach. For this approach, the as you can see, I am iterating it to all the queries only once. So the time complexity for this approach should be big of q only, and the space complexity for this approach should be big of q. So this is valid because q is only 3 into 10 to the power 4. This will definitely get passed. So that's all for today's video. Thanks for watching. Bye bye.